Now, let's zoom in on the arithmetic operations on number bases. Anyway, sorry for my voice. I'm a bit under the weather, so forgive my voice. So we are looking at the operations, basically the subtraction and addition on number bases. We will first look at the binary additions and then subtraction, and then probably with the same understanding, the concepts, we can use the same procedure to look at other number bases, right? And then I think from here we'll do last two episodes, and that will draw the curtains on number bases. So stay tuned. Now we were introduced to the arithmetic operations. Now we are going to look at this book, the examples here. I try to do as I do the video, do the calculations as I do the video, but it seems it's going to go against me. My hands will be covering the screen. So let's manage this. So we are saying that, for instance, if you are given number base, this is binary, right? So we have 0, 1, 0, 1 plus 1, 0, 1, right? So if you are to add this, we are to add 1 plus 1, which will be 2. Now this 1 plus 1 giving 2 is not what we want, because in number bases, in base 2, the digits should be either 0 or 1. So seeing 1 plus 1 giving 2, that means it's wrong. So if you are getting the 2, then we have to convert that 2 to what? Base 2. So 2 in base 2 will give us what? So this is what I've taken upon myself to do this one. This is the only example I will do, because that's the first example that I have to do so that you understand the whole thing. I know if you're on this channel, you know what we have been doing, and for the conversion, this is how it is done. So we use the long division like formula to do this. So 2 in base 2 will give us 1 and 0. So if you remember, we told you that 10, 1, 0 isn't always 10 like we see. On the face, just on the face, you may think it's 10, but it is not actually 10. If I should do it in binary, that would be 1, 0, and not 10. Hence, 10 is not always 10, right? So if you should do this, you know by now, this into this, 1, the remainder will be 0, then 2 comes again into this one, right? Will be what? 0, remainder 1. So hence, 1 and 0. So 2 in base 2 will be what? 1, 0. That is it. So now that we have established that, now we can say that 1 plus 1 will rather be what? 1 and 0. Now 1 and 0, under this column, we call it what? Ones column, tens column, and the hundreds column. That's why we did the introductory video for better understanding. So I'm not going to speak much. So if this is ones column, and now we are getting the answer to be 1 and 0, means that we have to write a 0 and then carry the 1 forward, because 1 and 0 cannot be under 1 and 1, because these are the ones column. So we can repeat it there. So we write 0 and then carry it, the 1, the remainder that you know, we carry it forward. If we should carry it forward, now we have 0 plus 0, then plus the remainder that we got. So it will be what? Another 1. So now we have 0 and then 1, and then if you should add this one into 1 and 1, we will once again go and meet 2. Now 2 cannot be written here, because we have established a trick that any number base that you are doing the calculation in, you should never have that figure. So if you are doing this calculation in base 2, means that you should not meet 2, the figure 2 in the calculation. That's another trick. So 1 plus 1, 2, no. So we take that 2 into base 2, which will give us the 1 and 0. So you can see that we get 1, 0, and then 1, 0, 1, 0. I think that's what we should get. So 1, 0, 1, 1, and 0, something of that sort, right? So I think this is the actual calculation here. So 1, this is 0, we bring the 1 here, so we get the 1, right? So this one, then we move on, this 1 plus 1, it will be 2. So 2 in base 2 gives us what? 1, 0. So 1, 0, 1, 0. That's the calculations. So with this understanding, I think we are good to go. It's as simple as that. Don't stress yourself. It's as simple as ABC. Now, if you should move on to binary subtraction, subtraction is basically the same idea of what you have done, but this time we are doing the subtraction. Now, there's another thing, that's another key or a trick that you need to be abreast with. That in subtraction, we are always borrowing if we cannot do the subtraction like on the face. Oh yes. So if you cannot do that, we have to borrow from the next figure or the next digit, and then we do that. Now, in base 10, in the regular system of counting, when we borrow, that borrowed value or figure, it was 10. Now this time, because we are being specific in the calculation, whatever we borrow will be that base, will be in the base that we borrowed. So that is it. So now, if you have 1 and 1, if you should subtract 1 from 0, in fact 0 from 1 is 1. Now we have 1 and 1. If you should subtract, it's giving us what? 0. Right? And then here. So here is simple. Now let's go on to another place where we have this. Now here, if you should take 8 from 5, this is not possible. So what it means is that we have to go and borrow. Now when you borrow a figure, let's say 1 for starters, if you should borrow 1 from 3, the moment you borrow 1 from 3, that borrowed figure is now what? The base is in that base that we are doing the calculation. So that is a trick. Now let's go and look at a typical example so that you know that this is base. It is in base 2, base 3, or base 4. So now wait, stay tuned. So let's look at these ones, especially this one. So here, what it means is that 0 from 0 is 0. Then 1 from 0 is not possible, so you have to borrow. When you borrow, that will become 2. So 1 from 2 will be 1. So this one is still simple. So let's not worry ourselves with this. Let's go to a particular one that will involve a lot, right? So with the base 2, I think they are okay now. So now let's look at this particular one, right? So we have 2, 3, 4 in base 5, and then 1, 4, 1, base 5. So make sure that any time you are doing a subtraction, they are in the same bases. If they are not in the same base, take all of them to base 10. That's the trick. If they are not in base 2, if they are not in the same bases or the same base, make sure you convert them, all of them, to base 10. Then you can do the subtraction, or simply they must all be in the same base. But the convenient one should be in base 10 so that you can do your subtraction. So that is the one thing. So I think I don't have to do an example specifically on this. Now, so we are taking 1 from 4. That would be 3. Now, here, it's not possible. Taking 4 from 3 is not possible. So if it's not possible, we have to go and borrow. Now, when you borrow, we learned that we are doing the calculation in base 5. So meaning, when you borrow that one will be converted to what? 5. Or automatically, that one becomes what? 5. So that 5 plus 3 will be 8. Now, when we have 8, we can now take the 4 out of 8, which will be 4 again. Bear in mind, we borrowed 1 from here, from these two. So now, 1 minus 1 is 0. There's no need bringing the 0. So hence 43, or don't even mention it 43 by 43 in base 5. This is as simple as ABC. So the same thing will be applicable to these and then that. So that is the basic calculations. So now we have covered addition and subtraction and these arithmetic operations on number bases. So it's the same idea. Apply them to all the bases that you come across, right? Yes, and now don't forget to go to this channel and like, subscribe, and then we have your structured lessons from chapter 1 to the current chapter, which is 5. So we will see you in the next one. Bye for now.